I am obsessed with circle theorem. So any year I see it in WAEC exams, once I get the equations after the exam, I always love solving it. Any circle theorem I see. And look at this one, quite tricky, but very easy. So our target here is to find angle TQP and then QTS. That is the angles we need to find. Okay? All right, so that is the angle we need to find, these two angles. Now, if you don't know the circle theorems properly, this question might seem very difficult for you, okay? So there are so many instructions here. We are told that this line here, PQR, is a tangent. Then this is a radius, okay? We have so many chords, and O is the center of the circle. Now, an angle TQP, TQP, this angle, that is the angle we need. But you know that the entire angle here is 90 degrees. So you can write that angle OQP is equal to 90 degrees. Why? This is a radius. And this line is a tangent. There is a theorem that says that the angle between a radius and a tangent is 90 degrees. So you can say radius and tangent. Angle between a radius and tangent is always 90 degrees. Also, this is a radius. This length also is another radius, meaning that this length and this length are equal. Radius is equal to a radius. So this triangle OTQ is isosceles. So you can say that if I call here M, it means that here will also be M, the base angles of isosceles triangle. Okay, you need to write all these things, but because of space, I may not write so many things. Now, M plus 56 is 180. M plus 56 degrees equal to 180, right? Reason, sum of angles in a triangle is 180 degrees. So M plus M is 2M plus 56 equal to 180. So 2M will be 180 minus 56 degrees, right? Then 2M will be equal to 124 degrees. So divide both sides by 2. So M is equal to 62 degrees. M is 62, meaning that this angle here is 62. The angle, not this angle, sorry. That is, the angle here is 62. But you know that the whole angle is 90, right? All of them is 90. So if I'm looking for this angle now, you can say, therefore, angle TQP will be equal to that 90 degrees minus the 62 we've gotten. 90 degrees minus 62 degrees. When you subtract, you get 28 degrees. So we've answered the first question. The first question is 28. Now, come to the second one, QTS. QTS. So we need the whole of this angle. Already we have gotten M as 62. We've gotten M as 62. So what we need is to get this one here. Let me show you. We only need to get this angle here, this one. Once we get it, add it to 62, you get your answer. Now, this topic is called some have eyes but cannot see. This is a chord. A chord leaves an angle at the center, 56. The same chord is leaving an angle at the circumference. So angle at center is twice angle at the circumference, right? So if the center is 56 degrees, the circumference should be 28, such that 28 plus 28 will give you 56. Angle at center is twice angle at circumference. I'm supposed to write this thing down with reasons to get your full marks, but because of space, I'm not writing so many things down. Now, consider triangle TSV. TSV, this triangle here. The sum of angles in a triangle is what? 180, right? Now, we've known that here is 28, here is 109, so we need to get the third angle. So, angle STV will be 180 degrees minus adding this and this. 109 plus what? 28. The reason is because they are sum of angles in a triangle. So angle STV becomes 180 minus this plus this should be 137 degrees, right? So angle STV becomes 43 degrees. That is 43 degrees. Therefore, for the second question, angle QTS, so find angle QTS will now be the sum of this and this. So here is now 43, while here M is now 62. So the total angle will be 62 plus 43 will be 62 degrees plus 43 degrees. When you add, you get 107 degrees. And this is just the solution to this problem. So if you got it like this, kudos to you. Bye.